Hello and welcome to this introductory course on learning to code in Python. My name's Ian Nace and I'll be your instructor for this course. Now Python is the fastest growing programming language right now, and in 2018 it's expected to exceed all other programming languages and become the fastest growing programming language of all. So in 2018 the average Python developer salary is $92,000, and it's only expected to go up from here, and right now the high end of salaries is $140,000. So the two main reasons that you should learn Python are that it's extremely readable and concise. There's more than 100,000 pre-built libraries, where usually you would have to code out these libraries yourself in other programming languages. And actually the third reason is that there's widely available resources because it's the most common programming language. And in 2014, Python surpassed Java as the #1 programming language taught to beginners. So I prepared a program for you to show you how we can print hello world to the console and how it's evolved over the years. So in 1679, binary was invented, and this is a hello world implementation on an older Windows machine. And as you can see, no human would be able to read this. And then assembly was invented, and as you can see, this isn't very easy to read either. You can't really find the letters for hello world anywhere within this program. Then in 1972, C++ was created, and as you can see, this is a whole lot more readable. And as we go up the ladder from binary all the way up to Python, we're going from lower level programming languages, because they're closer to the machine, to higher level programming languages because they're closer to human comprehension. And finally we have Python, invented in 1991, and as you can see, it just says print hello world, and that's a whole lot better than, say, binary with a bunch of ones and zeros. And here's the Zen of Python, which is Python's philosophy. And a summary of it is that beautiful is better than ugly, simple is better than complex, complex is better than complicated, and readability counts. And that's the main thing with Python. They really stress readability over all of these other programming languages. And this is huge for developers because it can make you code faster, it can make your code cleaner, and you can easily understand anyone else's code that you find. So I'm excited to get started, and let's go ahead and dive right into it. The first thing we'll be doing is installing Python and the Atom text editor. To install Python, go to python.org, go to this download section, and click on Python 3.6 or above. And if you see Python 2 there, make sure you download Python 3 or above, because we'll be using Python 3 throughout these tutorials, and there are differences between the two. And when you're installing Python on Windows, make sure you click the checkbox that says install to your path, because that will allow you to run it later on. And then come over to Atom, and whatever version of operating system you have, just click download. And once you have both of those installed, you can add them to your dock, and you can just do that by dragging the Atom program down into your dock, as well as terminal, and then just go to options and keep in dock. Now that we have Python and Atom installed, let's go ahead and make our first program, and this will be our hello world program. And this is a standard introductory program that just prints out hello world to the console. So go ahead and open up Atom and open up terminal. And if you're using Windows, you'll be using a program called CMD instead of terminal. And make half of your screen Atom and the other half terminal, or CMD. Now let's go ahead and save this untitled file as hello_world hello.py and make a folder on your desktop called python-introduction-code and go ahead and save this here. And I'm gonna unexpand this right here. So now we need to navigate to this file inside of terminal or command prompt. And you can do that by saying cd, and if you're on Mac, say desktop, and if you're on Windows, say cd c:/users / and then your username, it's probably just your first name. For me, it's Ian / desktop, and then one more slash. And this will navigate you to your desktop. And only do this one if you're using Windows, and it's just cd desktop if you're using Mac. So now we need to get into the directory that we just created, and that is called Python introduction code. So we're going to say one more time cd python-introduction-code. And as you can see, if you say ls, you can see that we have hello-world.py and zenopython.py, and we're going to be running hello-world.py. So now let's go back over to our Atom text editor and let's create this hello world program. So just type print and then in quotes say hello world. And that's all you need. So now just save this with Command S on Mac or Control S on Windows, and let's go ahead and say over here in command prompt or terminal Python, and if you're using Mac, say Python 3, but if you're using Windows, just say Python, and we'll say Python hello world.py. So we're calling Python and we're saying use Python, the Python compiler and interpreter, to open this hello world.py file. So now just click enter. And as you can see, it compiled and ran this program, and it printed out hello world to the console. Now we're going to discuss variables. So let's go ahead and make a new file by double clicking up in this tab bar, and we're going to save it as variables.py. So variables store values. So if I set a variable x to be equal to 100, then x stores the value 100. And if I were to print out x, it would print out 100 because x is storing that value. Now there's four main types of variables. These are integers, which is the one shown above, and that's a whole number. There's floats, which are decimal point numbers. There are strings, which are words and characters. So they can contain, if you put anything between quotes, double quotes, or single quotes, it's considered a string in Python. And you'll see in the future that this matters a whole lot. So we also have booleans, which are either true or false values. And these are going to be very useful in programming so that we can decide whether or not we want to do something based on whether a value is true or false. Similar to how computers understand binary, which is 1 or 0, true is 1, and false is 0. So we set those with either true with an uppercase T or false with an uppercase F. Now let's create a new file called comments.py. I'm going to save it as comments. So when you're programming, you want to document your code, and this is what comments are for. So say I printed out 100. I could write a descriptive comment above this saying this prints out 100. Now this isn't a very good example because oftentimes you want to comment very complex code that needs, if someone else were to look at it, they would need an explanation of what it does because they wouldn't be able to tell at first glance. But when you're commenting out, when you want to make comments, just add this hashtag at the beginning of the line, or you can do it after your code. And none of the code and none of the characters after this hashtag will be printed out to the console. This is basically for developers' eyes only. Anyone who's running the program won't be able to see these comments. So we'll just say this is a comment after a line of code. So neither of these comments will be seen by a user running the program, but only the developers will be able to see these, and they're commonly used to document and help other people understand the code. Now we'll be talking about basic arithmetic in Python. So let's go ahead and make a new file called arithmetic.py. And the arithmetic operators are probably all ones that you're used to: plus, minus, times, division, and then one more called modulus. So when we do arithmetic with Python, we're going to have usually two or more variables that we want to make an expression with. So we'll say we have a equal to 100 and b equal to 200. So let's print out a plus b, which would be 300. Or we print out a minus b, which would be negative 100. Or a times b, which would be, I think, 2000. And then a divided by b, which is probably about 0.5. And finally, a modulus b would be the remainder of the division. So say we divided 3 by 2. After we do 3 divided by 2, we'll have 1 remainder. So the value that it prints out would be 1. So I'm going to save this with Command S or Control S, then come over here and say Python, and Python 3 if you're using Mac, and then we'll say arithmetic.py. So we have 300 for a plus b, negative 100 for a minus b, 20,000 for a times b, 0.5 for a divided by b, and 100 for a modulus b. Now a little bit more advanced arithmetic. Say we want to set a third variable c to equal a plus b. So now the variable c stores whatever the value of a plus b is. So as you can see up here, the value of a plus b is 300. So now c will now contain the value 300. So if we were to print out c, you can see it now contains 300. And say we want to do something like a is equal to a plus b. A shortcut that we can use for that is a plus equals b. So we would be saying 100 equals 100 plus 200, which is 300. But the shortcut is, if we say plus equals, we're basically saying a equals a plus b. And we can do that for all cases. Say we have a equals a times b. We can say a times equals b, or a equals a divided by b would be the same as a divided by equals b. Now let's go ahead and make a new file, and we'll save it as concatenation.py. So concatenation is similar to arithmetic, except you're performing arithmetic on strings. So say I have one string, hello, and another string, world. Now you can perform similar operations like plus and times. So I can say C equals A plus B. And this will append the two strings together. So it'll become hello world merged. I'll just go ahead and print this out. So we'll say print C. I'll save it. And over here we'll say Python concatenation.py. And as you can see, it printed out hello world just merged together. But that's not really what we want. So we're going to add in a space between these two words. And we do that by saying A plus space plus B. So now let's save it and we'll run it. And as you can see now, we have a space between the two words. And you can also multiply strings. So let's say D equals A, which is hello, times 3. And this will print out hello 3 times in a row. Similar to how when you multiply a number, say you multiply 2 times 3, it's 2 times 2 times 2. When you multiply hello times 3, it's hello, hello, hello. So I'll save this and run it. Or actually we need to print out D. And as you can see, hello, hello, hello. Now let's create a new file called lists.py. So a list is a series of values. So we can say L is equal to 100, and these all go between square brackets, 200, 300, 400, and 500. Now, we have 5 values in this list, and all of these values can be accessed by their index. And it's really important to know how indexes work when we're talking about lists. So the number 100 is stored at index 0, the number 200 is stored at index 1, and the number 300 is stored at index 2. Basically, whenever you have a list of any kinds of values, the first value is always stored at index 0. So A would be stored at index 0, and the second value is stored at index 1, and so on and so forth, from 2, 3, all the way on to infinity. So if I were to say print A at index 0, it would print out the character A. Or if I were to say print L at index 0, it would print out the number 100. If I were to say print L at index 2, as you can see up here, we go from index 0, index 1, index 2. So we'd be printing out the number 300. So let's just go ahead and save that and run it. And we're going to say Python 3 lists.py. So we have A at A of index 0, we have 100 at L of index 0, and we have 300 of L at index 2. So when we have lists of values, it's very useful to be able to add values to the end of this list, and we can do that by saying .append. So if we say L.append 600, it's going to append 600 as another value in this list. And as you can see up here, we have index 0, index 1, index 2, index 3, index 4. Now 600 will be stored at index 5. So if we say print L at index 5, it'll be 600. And now later on, we're going to go into list methods where we can interact with the lists in much more meaningful ways. But for now, that's a good summary of how lists work. Now let's create a new file called tuples.py. And tuples are very similar to lists, but they have a few very important differences. So if we were declaring a list, we would use square brackets and add a few values inside the list. But when we're declaring tuples, we use parentheses and add the values inside the list. The most important difference between a list and a tuple is that a list can be edited while a tuple can't. And the technical term is immutable versus immutable. So if I were to try and append 400 to a list, it would work. But if I tried to append 400 to the tuple, it wouldn't work because the tuple is immutable. Now I'm just going to go ahead and print out the list and the tuple. And we'll see what happens when we try and append values to each one. So I'm going to say Python tuples.py. And as you can see, tuple object has no attribute append. Let me delete this line right here. We'll save it and run it again. And as you can see, it printed out 100, 200, 300, 400 for the list, and 100, 200, 300 for the tuple. And remember, tuples are declared with parentheses, while lists are declared with square brackets. Tuples are immutable, and lists are mutable. Now let's create a new file called dictionaries.py. And dictionaries are different from lists and tuples because dictionaries are key value pairs. And it's very similar to, for example, Webster's dictionary, where you have words and their definitions. So I'm going to say D equals, and then we're going to have a curly brace to indicate that this is a dictionary. And we're going to say word to indicate the key value, the key of this pair, and then colon, and we'll say definition. And we can declare as many of these as we want. So we'll say word 2, colon, definition 2, and word 3, colon, definition 3. So these are a bunch of key value pairs stored as strings. I'm going to make a simple one down here, and we'll say the key A contains the value 43, key B contains the value 56, and key C contains the value 89. So now, if I were to call A at the index of a key, so for example, the dictionary A at the index of B would be the value 56. Because as you can see up here, index B, well, technically key B contains value 56. So if I were to print this out, it would be the value 56. So we'll say Python dictionaries.py and see it prints out 56. Now, if I were to print out D at the key word 3, it would print out the corresponding value, which is definition 3. And later on, we'll go into how to mutate dictionaries and loop through them in efficient ways. Now let's go ahead and create a new file, and we'll call it conditionals.py. Now, conditionals are sometimes called if statements or if-else statements, and these are all about testing whether something is true or false. So we'll say if one condition is true, then do something, else do something else. So let's set a variable called a equal to 1 and b equal to 2. And we'll say if a is greater than b, print yes, else print no. And 1 is obviously not greater than 2, so we should see no. So we'll save this, and we'll come over here and say conditionals.py, and it says no. Now there's a couple of operators that we can use to test the equality. We can either use greater than, less than, greater than or equal to, less than or equal to, which when we're talking about equality is 2 equal signs. And that's important to remember. When we use 1 equal sign, it's called the assignment operator. And when we use 2 equal signs, we're testing for equality. And another thing we can use is not equals. So if we're saying if 1 does not equal b, then it'll print yes. So let's test if a is less than or equal to b. Print yes, else print no. And obviously 1 is less than 2, so it prints yes. Now let's test not equal to. Yes. Equals. No. Now let's go ahead and create a new file called loops. And we're just going to save this one as loops.py. Create a new file here. And loops will really make you realize the full power of programming. So we can loop through a piece of code 100 times, 1,000 times, 100,000 times, or even 1,000,000 times. And with the current power of processors, looping through something 1,000,000 times really won't even take that long. So let's go ahead and create a loop. And this loop in Python is called a for loop. So let's say for I in range 10,000, print I. So this is going to go from 0 all the way to 9,999 and print that out each time. It's looping through like this. It's going 0, 1, 2, 3, 4, 5, and so on. So let's save it and say python3 loops.py. And if you can see how quickly that happened, it just printed out 10,000 numbers to the console. Let's try 1,000,000. We'll save it and run it. So it just printed out 1,000,000 numbers to my console. And as you can see, we can truly harness the power of computing by creating loops and combining these loops with conditionals in order to make decisions happen at an extremely fast rate. So another kind of loop is a while loop, and this takes into account a specific condition. So we'll say while I is less than 7, print I. And we'll initially set I equal to 0. And while we're looping through, we're going to increment I. So we'll say I plus equals 1. And remember, that's basically I equals I plus 1. So if I is equal to 0, it's 0 equals 0 plus 1, or I equals 0 plus 1, and that's 1. Then I becomes 1, and so on and so forth. It'll keep incrementing from there, and it's called an incrementor. So let's go ahead and save this and run it. And as you can see, it printed up from 0 all the way up to 6, because once I hit 7, it broke out of the loop. Now let's create a new file called string methods. So strings can be manipulated in a few different ways. So first of all, let's create a string. It'll just be A, B, C, D, E, F. And let's print out the character at the 0th index. So this is similar to a list. So we'll say Python string methods.py. And it printed out A because A is at the 0th index of the string. And now let's print out a substring. So let's say we want to print out everything from the 0th index to the 3rd index. This would be A at the 0, B at 1, C at 2, and it would be up to but not including D and D at 3. So this will print out A, B, C. Or we got to save it first. Now we can add a third parameter. And when we add a third parameter, we have the start, the end, and the step. So let's say 0 through 4, which would be A, B, C, and D. And then let's add the step. So if we say 2, it'll skip over A and go to B, and then it'll skip over C and go to D. So imagine the step is like a skip. So I'll save this and run it, and it prints out AC. Now that we know about getting characters, substrings, and subsequences, let's do some basic string methods. The first one I'll show you is find. So let's print out the result of s.find C. And what this will do is return the index of C. So I'll save it and I'll run it over here. And you can see it returned 2, and that's because C is at 0, 1, 2. And now let's do replace. So say I want to replace all of the D's in that string to Z's. I can just say s.replace D, comma, Z. So A, B, C, Z, E, F. And finally, let's say I wanted to count all of the letter E's in the string. I can just say s.count E. And there's only one E in this string. Now let's create a new file called list methods. So lists can also be manipulated like strings, but lists have a few advantages because they're sorted information. So let's go ahead and get started. So we'll have one list called A, and it'll have the values 1, 2, and 3. Another list called B, it has the values 4, 5, and 6. Now we can combine these two lists together with simple addition. So we can just say C equals A plus B. And let's print out C. And this will take 4, 5, and 6 and append it to the end of 1, 2, and 3. So I'll just say Python 3 list methods .py. So it created a new list 1, 2, 3, 4, 5, and 6. And another list method we can use is one that we can use to create lists. So let's say we have a string which contained A, B, C, D, E, and F, characters separated by spaces. An easy way we could create a list would be to say z equals s dot split. Now this split function takes every space and basically adds an element to the list when it hits a space. So it'll add A, then it'll add B, then it'll add C, D, E, and F to the list Z. So if I were to print out Z, it would look similar to S, except it would be in list format. So as you can see there, it stores all of those characters. So now let's say, now that we have a list Z, which contains all of these characters, let's perform some conditionals. So we'll say if A is in Z, so we just say if A in Z, print A is in Z. Else we'll print A is not in Z. I'll save it and we'll run it. So A is in Z. Now let's test the letter G. So it's A is not in Z, basically means G is not in Z. And we can also say not in, so we'll say if G not in Z, and if that's true, we'll say G is not in Z, else G is in Z. So I'll save it and run it. So G is not in Z. Now something else we can do with loops, which is very convenient, is we can say for I in Z, print I. So this is going to loop through the list, and each time it loops through, it's going to store one of the values of Z inside of this variable I. So it'll print out A, B, C, D, E, and F. Another thing we can do with lists are perform some of the built-in methods. So let's say Z dot, actually let's create a new one called Q, and we'll store 4, 5, 3, 2, and 7. Then we'll say Q dot sort. Now this will sort all of the values to be in ascending order. So as you can see, 2, 3, 4, 5, 7 is sorted correctly. If we want to reverse it, all we have to say is reverse. So you can see the reversed version there. Now let's say we want to get the number of times that 3 appears in this list. Actually, we just need to print this entire thing out. We'll save that, and it should only appear one time. As you can see there, 1. We can also get the index. So we'll say q.index. And right now, as you can see down here, 7 is at index 0. So if we say q.index 7, it should return 0. And finally, let's get the length of the list. So let's just len q. And as you can see, this list has 5 elements, so the length is 5. I need to save it. And then we can get the minimum element and the maximum element. So the minimum element in this list is 2, and the maximum element is 7. Create a new file called typecasting. So when we typecast variables, we're converting them from one type to another. So if a variable is initially a string, but we want it to be an integer, we typecast the string to an integer. So for example here, if I have a string that contains 237, I can't do any arithmetic operations on it. I can only concatenate it because it's a string. But if I want to convert this into a string, I could just say b equals, or I mean an int, I just say b equals int a. So this takes the 237 string value and converts it into an integer that can perform mathematical operations on. And the same goes for integers to strings. So I'll say, now that b is an integer, I want to convert it back to a string. So I can just say str b. So let me print out b, and I'll print out c. And this is just typecasting.py. You can see they're both 237, but one is in an integer format and the other is in a string format. An easy way we can see this is if we just create a list, and we'll just say x is equal to b comma c. I'll save it and run it. I'll print out x. So the first one is an integer, and c is a string, because you can see it has the quotes around it. Now, converting strings to integers is probably the most common ones, you're going to do in Python. Next, let's create a new file called escape sequences. And escape sequences allow you to print out characters that you would otherwise not be able to print. So, for example, something like a double or a quote, you would not be able to print out because Python would then think you're trying to create a quote around these first two or second two, and it would just cause a whole bunch of problems. So we could escape that with a backslash. Now it will just print out a quotation mark. So let's run this with Python 3 escape sequences.py. So it prints out a quotation mark. And the other common ones that you need to know are \n for a new line. So this will go down to the next line. So say if I have hello \n world and print that out, it'll print it out on the next line. You also need to know \t. Let me add a few in here. This is the tab character. So you see it adds a few tabs between there. And then we have backslash single quote. And we also have backslash A if you're on Windows and you can make a bell sound. And those are the main ones that you should probably know. And that's it for escape sequences. Let's create a new file called user input. And now I'm going to show you how you can get input from the user's keyboard. So let's create a new variable called x, and we'll say it's equal to input enter a number. So whenever the user enters, will be stored in the variable x. And then we'll print out x times x. So we'll say Python 3 user input.py. So we'll enter a number, 4. Oh, and this is something you also need to know, is that whenever you get an input, you need to convert it into an integer if you want to do mathematical operations on it. So we can just do that by typecasting this entire thing to an int. So now we enter a number, 4, and it prints out 4 times 4, which is 16. Now let's create a new file called functions. Now a function is a piece of code that performs, just like it says, a single function. And it's really important that you only have these perform one single function, such as adding two numbers together or printing out a menu or something like that, just a single function. And these are defined with the keyword def, and then we say what the name of the function is. So we'll say add two numbers. And now this is the block of code that actually says what this function is going to do. So we'll say print, or actually with a function we need to say return, and this will return the values x plus y. And we're actually going to pass in x and y to this function by setting a parameter list here. So later on, if we want to call add two numbers in our code, this function, all we have to say is say some variable c is equal to add two numbers, then we'll have 3 and 4. So in reality, this is going to pass 3 and 4 into the add two numbers function, and then this function is going to return x plus y, which is 3 plus 4, and store that in C. And let's say we have a second function called print menu, and this one doesn't have any parameters. We'll just say print, this is a menu, we'll save that, and then later in our code, if we want to call this print menu function to print out our menu, all we have to say is print menu. So up here we're defining the function, and down here we're calling the function. So I'll just save this and say Python 3 functions.py. So this called the print menu function, and it came up here and printed out that menu. And functions are very useful in making your code extremely readable. If you have a bunch of functions that only perform one task, and you divide up your main code into all these functions, people who come to your code will be able to read it a whole lot better, And when you go back to look at your own code, it'll make a whole lot more sense if you have everything divided up into functions. Let's go ahead and create a new file called modules.py. And modules are software packages that we can bring down into our project in order to use code that's already been created. So for example, if we wanted to access an API online, or we wanted to write something to an Excel worksheet, we don't necessarily want to rewrite all of the code to write data to an Excel worksheet. That's where a module or a package comes in. We can just download the package, and someone else has already written all the code required so that we can just work on the front end and write things directly to that Excel workbook. And there's hundreds of thousands of packages which can be accessed at pypi.org, pypi.org. And say we want to search for a specific package, like something to do with astronomy. I've heard of AstroPy. It's a really nice software package for astronomy tools. So now I want to install this package. On Mac, I would come down to my terminal and say sudo pip3 install AstroPy. On Windows, you say just pip install AstroPy. So let me go ahead and run this on Mac. So now it just downloaded AstroPy from the internet, and I now have that software package inside of my local machine, so I can do whatever I want with it. There's also packages for data science, AI. There's packages for anything you can think of. Just go to pypi.org and browse through there. And once you have your package installed, all you have to do is just come over to your code and say import AstroPy. And now I have that entire AstroPy framework within my project. Python also has some built-in modules such as math. So you can get the floor, square root, ceiling of numbers, you can round numbers, and that's all built into Python. But when we want functionality that's kind of outside the realms of the core Python, we need to go to pypi.org, find that package that we want, and install it using pip. Let's create a new file called pep8.py. Now pep8 is a coding style convention for Python. So this is basically the conventions that you need to follow in order to write proper Python. So it has things like how you need to format your variables, how you need to format your file names, whether you should use tabs or spaces, and how many spaces should your indentation be. So I'll link this resource, but you need to really look into this pep8 style convention guide, because when other people look at your code, they're going to expect you to be following the pep8 standards and to have your style, and for your style to be along the lines of Python. If you're coming from a language like C or C++, you probably name your variables with camel case, and camel case is lowercase first word, like this is a variable, and all the words after the first word are uppercase. In Python, rather than camel case, you're usually going to use an underscore for methods, variables, and anything along those lines. So I really stress, again, for you to come to this website and go in depth into all of the style conventions and really master them, so that when other people look at your code, they know that you have good style and that your code will be easy to read and follow. GitHub is an extremely important tool for developers. You can post all of your code here and store it in repositories. Repositories allow you to go back through your code and get older versions in case something goes wrong in some of the newer versions, and also allows your entire team, if you're on a team, to stay up to date with all of the code and everyone can be on the same page. So this is GitHub right here. You can explore everyone's projects. Everything's pretty much open source. So go ahead and create a profile here, and we're going to post our first project to GitHub. After you've created a profile, go to your desktop, create a new folder, and name it my-github-project. Now let's open this up in Atom. You can do that by just dragging it into the Atom icon. And now let's create a new file, and we'll save it as github-proj.py. And let's just make it print out, this is my first GitHub project. Let's save that. And now we have a directory that is ready to be uploaded to GitHub. So come back over to GitHub, click on this plus symbol, new repository, and we're going to name it my first project. We're going to make it public, uncheck initialize this repository with a README, and go ahead and create this repository. Now we have a master repository that exists on GitHub's website. The next thing we need to do is come back over to our terminal or command prompt and navigate to the My GitHub project folder. So in my case, I'm going to do cd ... to go up to a parent directory. Then I'm going to go into My GitHub project. And then I'm going to create my GitHub repository here. I do that by saying git init. Then I'm going to add all of my files to this GitHub repository by saying git add dot. Then I'm going to make a commit message, and a commit message is for specifying what happened in that commit or in that update. So I'll say git commit -m, and then in quotes I'll put my message, and we'll just say first commit. Now we have a commit ready to be uploaded to the master repository. So come back over to GitHub, copy this remote repository, paste it in here, and now we're adding the master repository down to our local repository so that we can push up our changes to the master repository. Now we have it added. Now the last thing we need to do is push these changes to the master repository. So we say git push-u origin, which is our local machine, master, which is the repository located on GitHub. And as you can see, it's uploading. Now I go back over to my repository, refresh it, and there we go. I have github-proj.py in my repository, and you can see located in this file is my code. Congratulations on completing this course. I hope you see now why Python is the fastest growing programming language of all. I'd also like to invite you to take the next course on your journey. We'll be doing some intermediate concepts like calling APIs and parsing JSON. And I'm going to give you all of the source code at the end. So I'm going to guarantee that this course will take your skills to the next level. And if it doesn't, I'll give you all your money back. You can use the coupon code PythonBonus, all one word, to save 95% on the course, and I'm only doing this for my current students for a limited